Thank you. Yeah, so I'm really excited to share with you what distributed authorization is and why we built it. This is something we've been kind of building towards at Oso for a good 4 years at this point. And so it's really fun to see it come to fruition, whatever, had to happen. It's kind of a new concept. It's a new way of thinking about authorization. It's actually kind of a new approach to a kind of typical microservice problems in general. And so like with any new technology, I think it's, we're still figuring out the right way to talk about it and describe it to folks and things to call it. And so, a big goal of this discussion here is to get, sorry, I'm just gonna mute someone. Yeah, a big goal here is to get you all involved as well. And like, we want to open this up with a discussion at the very end of it. So please do like answer questions throughout and, as we sort of go on this journey of what this means. So the schedule for today. So I'm going to kick things off. I guess I didn't say anything earlier, but yeah, hi, I'm Sam, the co-founder and CTO at Oso. I'm going to kick us off with a bit of a high-level overview of what this distributed authorization thing is and means and why we care about it. I'm then going to hand it over to my esteemed colleague Vijay, who is an engineer at Oso and sort of one of the co-creators of this core feature. He's going to show you what it looks like in a kind of concrete use case. I'm going to wrap it up with a little bit of a kind of behind the scenes look at what we're doing under the surface to make this thing happen. Kind of share with you some of the technology underneath this. And then we wrap it up with a kind of free-form open discussion Q&A where you can kind of ask us about anything that came up around this. So a lot of this webinar, we're going to be using a kind of GitHub inspired example for, as we talk through some of these concepts to try and ground it in, nouns and things that people are familiar with. So for this, kind of maybe put yourself in the frame of mind of somebody working at GitHub, maybe on their authorization or on their application. And it's going to be a sort of a service-oriented version of GitHub, right? So there might be kind of multiple services and service boundaries and teams working on them and things like that. So upfront, right, like when building out our GitHub application with a few different services, maybe we have an issues service that manages GitHub issues. And then we have like the account service that's kind of that grab bag for like users and orgs and repositories and things like that. Maybe that's our two services to begin with. And, without doing any design up front, we might just, have the authorization logic and the authorization data all coupled inside of those services, right? So when I need to decide, can I use a close an issue or something, I might, I look in my database, I see the data I've got about the users, I might need to have that role data or something. I then go, try and answer that question as best I can. What I maybe kind of touched on there that often is challenging about doing that is some of the stuff you need to answer those questions, well, it lives across all of these services, right? So like, again, can I close an issue? It's going to depend on maybe my like organization role, the repository the issue belongs to, the organization the repository belongs to, my role in that organization. And so trying to do like authorization just in each individual service by itself ends up being this like very kind of messy, distributed monolith style approach where you end up having like cross-service calls where you're making requests to other services, trying to fetch the data you need. The account service, like the people managing roles, they need to know who, like what permissions exist on issues. And so like the authorization logic is coupled with the issue service again, and it can be kind of messy. And so like, as you often do in like a service-oriented architecture, you say, well, we've got a shared concern, let's pull it out. And so that's what you do in an ideal world. You'd be like, cool, let's take our authorization logic, let's take our authorization data, and let's put it in a central authorization service. Sorry, we've got a bit of an echo going on. Steffi, if you can find that and mute it, that'd be great. Thank you. Yeah, so like in an ideal world, you pull it all out. However, this kind of idealized version of like, yay, let's just pull out authorization, so is assuming that you have this like, perfect, clean separation between.
Sam, you're muted.
Steffi, I think you muted me instead. Sorry. Thanks, Gabe. So this assumption, sorry, I don't know where I cut off, but basically this kind of like centralized version of authorization depends on this assumption that like your application concerns and the data is perfectly separable from your authorization data, your authorization concerns. But that's really not the case very frequently. It normally looks more like this. For example, again, like coming back to that issues example, can I close an issue depends on knowing what repository it belongs to and the permissions I have on that repository. So issue belonging to a repository is now fundamentally important to answer authorization questions. But at the same time, it's like really a core part of how the issue service functions. The issue service knows what repositories issues belong to. Like when you create one, you create it in a repo. When you list them in a repo and things like that. And so what that ends up meaning is in practice, when you could do this approach of like pulling your authorization out into a separate service, it looks more like this, where this is basically these little auth data blobs kind of staying inside each of the individual services as well as being inside the authorization service. And so to make that work, you basically need some way of making sure that your data that you need to answer authorization questions, the part that is overlapping with the application data, you need to find a way that you can get it in both places at once. And so there are various approaches to do this. You can like send the data along at a request time and like package it up and send it along. You can duplicate data between the two and have like a replication process. You can go like fully like service agnostic data model and have like event sourcing so that nobody owns the data and it just gets propagated everywhere. There are kind of like pros and cons of all of those. But like fundamentally, one of the things that at Oso we don't like about that is we don't want to be the ones to tell you must conform to a specific architectural model in order to have your authorization be decoupled. That feels like a really big requirement to put on people, as well as often just being very inefficient, like needing to synchronize this data around. There's like a second point in here, which is a little bit more subtle inside this diagram. But in doing this approach of like synchronizing the data back and forth, it can also make it very inefficient to perform common authorization operations, like what are all the issues I can see? Because you might be sending all of your issues data to the service and then getting back a long list of all the issues you have access to and doing this kind of like big back and forth between the two. And so that brings us to distributed authorization, which we see as kind of being this like best of both worlds where we kind of get like the right balance of like what should live where. And so the difference here is rather than centralize all of the data, you just centralize data that is necessary. It's like shared data that is necessary for any application or any service to do authorization. So this might be like org roles data, repository roles data. But data that individual services potentially own that isn't shared across services can stay where it is. It's kind of represented by this like strange green dashed arrow as saying, we don't actually put this issues data, issue belongs to a repository into our service. We're just going to reference it in some magical way. Right. And so this helps us with those two things I was referencing. So one, we've like massively reduced the amount of like data we need to replicate into various places. This issue service has no data replication it needs to do at all. And secondly, we can actually now start doing common authorization operations like filtering issues users can see based on data living inside of databases, based on fields living inside of databases, which databases are really, really, really good at doing. And so that's where we'd like it to happen. At this point, I'm going to hand it over to Vijay, who's going to go and give you a concrete demo of basically the concepts I was just describing now. So over to you, Vijay.
Thanks, Sam. I'm going to go ahead and share my screen. Let's see. How does that look? I've never done this mode before. Oh, neat. Okay, cool.
Looks great.
So we're going to do this in the context of the Git Cloud sample app. It's a GitHub-like application, just because everyone's familiar with GitHub. And so Sam went over a bit of the why distributed authorization is necessary and helpful. I'm going to go over what it actually looks like to use it in your application. And I think not only does it clean up your data model a lot, it also can be the fastest way to integrate with Oso, and it's a really simple integration when you look at it. So I'm going to walk you through what it looks like to integrate distributed authorization into the Git Cloud sample app. So in particular, we have multiple different services. We have the account service, which manages users, organizations, repositories, and roles on organizations and repositories. And we're standing up a new service. Let's say we got a feature request where people want to have issues like bug reports reported on repositories, and we're standing up a new issues service to manage the issues data. And so this might be what that would look like. So I'm going to go over to this web app that I have running. This is the Git Cloud web app. And I'm going to go over to this issues page, which shows kind of a list of all of the issues that it's supposed to show a list of all the issues that the current user is authorized to read. I'm logged in as a certain user, and it's showing us all of the issues across any repository. And as you can see, there's no actual authorization implemented into this just yet. It's just querying all of the issues from the database and displaying it on a web page. And our goal is to add authorization to this. So you can see when it's trying to show the creator and repository, we're getting an error not found because we're not actually authorized to read all of these repositories. We're not actually authorized to read all of these issues. And so our goal is to fix this. And as you can see, when we display the issue to the user, some important application data is which person created the issue and which repository the issue belongs to. And so we want to display that on the page, so that is application data. So now I'm going to go over to kind of what the endpoint looks like right now, and it's a really simple Flask, Python Flask app. And as you can see, this is a really simple endpoint. We're just getting this endpoint, and we have like a little flag for toggling on or off whether you're checking the read permission or the close permission, but that's not actually being used at all right now because there's no authorization here. We're just using SQL Alchemy to query all issues from the database and doing no filtering on that and returning that, and that's why we don't have authorization. And so I'm going to show you what that database kind of looks like. I just ran, this is PSQL, I'm just running a select star query against the database itself. And here we have issues with IDs, and they have titles. And as you can see in this database, we have this application data around what the ID is of the repository the issue belongs to, as well as what the ID is of the user who created the issue. And that's all necessary for us to store in our database because it's displayed in the issues service. So the front end is just doing a request to this issues microservice, and we're just returning this data. So our goal is to add authorization to it. So to see what that would look like, let's look at our authorization policy. So this is just my polar file that I'm using across all of the Git Cloud microservices. And for issues in particular, I have certain permissions set up. So in particular, let's look at the close permission. And you can see that here's one rule that governs when somebody is granted the close permission. It's when they
Hey,
have.
Jay, it's a little hidden behind your head right now. The downside of the lovely overlay is, yeah, if you just scroll it up a bit, or
I'll just share the normal way. Or that wasn't the normal way. There we go. Okay, so yeah, so as you can see, you're granted the close permission if you have the manage issues permission on the repository the issue belongs to. And so this depends on a few different things. It depends on what permissions people have on repositories, as well as which repository the issue is related to. And repositories and organizations, all that data is already centralized in the Oso Cloud service because that pertains to many different microservices, including this issues one. But data about which repository each issue belongs to, right now it's just in my database. And similarly, you can also close an issue if you are the creator of the issue. And that depends on this creator relation here. And information about who created which issue is also currently stored in my database, and we need to figure out some way to get Oso to help us authorize it, even though the data is just stored locally in my microservice and not in Oso Cloud at the moment. So one way we could do this is by going through every place that an issue is created or updated or deleted and adding oso.tell, oso.delete, and all of that stuff necessary to store the data in Oso Cloud. And then you have multiple sources of truth, and you have data synchronization and duplicated data across multiple data stores. Not great, and that's a lot of integration effort. So I'm going to show you kind of the key ingredient in distributed authorization, and that's this YAML file that I have here. And as you can see, the main thing that's going on in this YAML file is we have a mapping between Oso facts, so has relation between an issue and a repository, or has relation between an issue and its creator. We have a mapping between those facts and how to get those facts from the database. And so this kind of ties together a lot of different pieces. It related to your authorization policy. it's related to your database schema. And so once I write this YAML file, let's say I just wrote this and I want to see whether it's correct or not, we actually have a tool that we built into the CLI that allows you to validate this against both your authorization policy as well as your database itself. And so if I run this Oso Cloud validate bindings command, I'm passing in the YAML file, my authorization policy, as well as a connection string for my database. And I run that and I see relation issues does not exist. Looks like I have a typo in the SQL query. So it tried running it against the database. That didn't work. So I'm just going to run this one more time after fixing that typo. And the policy itself validated successfully, but it looks like I misspelled the is closed fact in my policy. As I look at my policy, I see that I have this is closed attribute, but I forgot the E, so I'm just going to go ahead and fix that typo. And now, if I run this one more time, all validation passed. So this Oso Cloud Validate Bindings CLI tool helped me to get to a point where I have a working facts.yaml file that represents the data binding between my Oso Cloud data and my database that's storing the data. So now I just need to integrate this YAML file into my application and get Oso to use it in order to perform authorization. So the first step I'm going to do on that is I'm going to go to where I'm initializing my Oso client, and I'm going to add one more argument to the constructor call when I initialize the Oso client. So I'm just going to add another field called data bindings. This is Python, and I'm just going to add in the facts.yaml file there, and that now Oso is getting initialized and it's aware of the YAML file that configures the mapping between Oso data and my database. And now in order to use this to actually perform enforcement, I'm just going to go back to that Flask endpoint that I had earlier, and I'm just going to call into Oso to perform some authorization. So I'm going to make an authorization filter. I'm going to do oso.list local. So the distributed data methods end with this local word. It's like it's analogous to the oso.list command, except it's distributed. And so I'm just going to do oso.list local. And then I'm just going to pass in a user. So I'm going to say like type user. Got it mostly right from Copilot. All right, so type user ID, I'm just getting the current user from my authentication, however I'm doing authentication in this application. So I'm getting the current user, and then like I mentioned before, we have like a query argument that's dictating whether we're checking for the read permission or the close permission. So I'm just taking this permission variable and I'm passing it in as the permission we're checking for. And then the type that we care about is the issue type. We're authorizing issues. And then one last thing that isn't in the typical list local, it isn't in the typical oso.list method, is I'm also going to say the name of the column that corresponds to the identifiers that I use in Oso. And then I'm just going to add like a print statement just so that we can see this later. And then the last step is I'm just going to add this filter to this SQL query. So we're querying issues. I'm using SQL Alchemy for this. I'm just going to do .filter text authorization filter. So I'm just taking this filter that we got from Oso, applying it to the SQL query, and good. So we just integrated Oso authorization into this endpoint using distributed authorization. So now I'm just going to go over to my, I'm running all of these services locally using Docker Compose. So I'm just going to run another Docker Compose to redeploy everything. And now if I go back to the browser, I can see that I'm scrolling down. I don't have any of those authorization issues anymore. I'm only looking at repositories that, issues that belong to repositories I'm authorized to read. And then we can make this a little bit more interesting and filter to only show issues that I can close. You can imagine this is useful for if people want to view for all the issues they need to triage, for example. And let's just look a little bit deeper. Recall that the two ways you can be authorized to close an issue are if you have the manage issues permission on the repository it belongs to, or if you're the creator of the issue. So just to get a sense of kind of how this filtering is working, and so this is kind of the ta-da moment. We have authorization working, and it just took like a few added lines, and we didn't have to add oso.tells everywhere. And Let's just make sure that everything's working correctly. So we have this first issue, and the repository ID, it looks like it's 64, and my user ID is 72. And we know that information about permissions on repositories are actually stored centrally in Oso Cloud. So I'm going to go back to the terminal and just do a little Oso Cloud authorize, and user 72, repository 64. Gonna hit that, and looks like it is allowed. And now we know that's why we're authorized to view this issue, because, or why we're authorized to close this issue, because this issue belongs to a repository that we have the manage issues permission on. So we're going to scroll down a little bit more, and then let's take a look down at this repository, or this issue, then range west. We are the creator of this issue, and it belongs to a repository with ID number 1. And let's check whether we have the manage issues permission on that repository, and it turns out we don't. But like I said, the reason we're authorized to view this one is because we are in fact the creator of this issue. I'm logged in as user Brandy20, and the creator of this issue is user Brandy20. And so Oso is using all of the logic you wrote in your authorization policy, as well as the data in the issues database that belongs just to this microservice, and performing authorization. And so to go one click deeper into how this kind of works behind the scenes, let's get an understanding of how Oso may achieve this. And so one way that to get an insight into that is to see what are all of the issues what are all of the repositories that the current user has the manage issues permission on. So I'm just going to change this command to Oso Cloud list and remove the ID there. And I get a list of issues that the user 72 has the manage issues permission on: 63, 64, 65, 66, 67. And remember, when I added this enforcement to the endpoint, I actually printed out the SQL that we get back from the oso.list local method. So let's actually go to our Docker logs and see what SQL is getting printed out, and see if we can understand it a little bit. So I'm going to run Docker logs F on my services, on my issues service, and we can see permission equals close. And the SQL is kind of messy, and that's why it's nice that we don't have to write it ourselves, or you don't have to write it yourself. Oso writes it for you, but you can see kind of under the hood of what's going on here. It's taking exactly, it also figured out based on the server-side data and how it needs to split up what it resolves in the server side and what it resolves in your database, and figured out that it needs to look at repositories 63, 64, 65, 66, 67, because those are the ones that if the issue belongs to it, then you can close the issue. And then we have a union, and we have this other clause where it says if the creator of the issue is ID number 72, then we're also authorized to close. So it unions those two things together and applies this filter to your query, and now you have a query that returns just the issues that the current user is authorized to view. So that's kind of a quick look into the under the hood of how we built an distributed authorization and how it works. And to get a more thorough look into how distributed authorization works under the hood, I'm going to hand it back to Sam.
Awesome. Thank you, Vijay, for going through all of that. While you were talking, we had a fantastic question in the chat as well, which figured is worth spending a little bit of time on before we move on, from Appeal, if I'm getting that correct. And yeah, let's see if I can find where all the tabs and stuff have gone so I can talk through it. All right. Yeah, so basically the question in the chat was, oops, not this one. The question was around basically when we're doing that distributed authorization, can we do it between, can we potentially do this query across like multiple services? So for example, we're talking about like, issue service currently it's using data inside of its database and data stored inside Oso. I think as I understand it, the question was like, well, what if we wanted to use data from the account service and Oso and the issue service, something like that? Like, can we stitch together like multiple different services when we're making the query? And today the answer is basically not yet. I think as I talk through some of the like how Oso works, I think might make it clear that we could definitely extend this from 2 services to multiple services. But basically today we sort of have this like the way you solve this is any data that needs to be used across basically more than one service would go inside of Oso, and that can be shared across any of these like any of these services. So we see that commonly with like role data or like custom roles, authorization configuration data, things like that, and individual services managing their own. But yeah, it could be possible that in the future, for example, and like an idea we've been exploring is that you could have a third service here. Maybe you've built a issues commenting service or something, or I know you've got your like GitHub Action service that requires that you need to know like the permissions you have on the issue service, because like you can, I don't know, run a PR if you're the issue. I don't know, you can merge a PR if you're the assigned it on the issue or something like that, and you start needing to involve like multiple sources of data. There's maybe a world where Oso could help stitch together data from like multiple databases in answering that. But yeah, I'd love to like dig into that more maybe in on a separate chat. Is Oso database backend agnostic as Postgres only? So today this works for Postgres. That's the first one we built was for Postgres. I guess like within our internal testing, we also use SQLite because we use that heavily inside of Oso as well. And we sort of basically plan to extend this to other relational databases kind of as our like next priority. And then we're also looking into maybe in a longer time period around integrating with other like data stores, like document databases, Elasticsearch, things like that. Yeah, I think you'll see like a lot of the stuff we're doing is we're not doing very like esoteric SQL. It's generally like some joins, some comparisons. So we do expect that we'll be able to extend support to most like SQL dialects pretty easily. But yeah, we're not there yet. Cool. If there aren't any more questions, I'm gonna got some more. I see. Good question from Martin as well. Let's stick on this. Is the default connection pool the service used for database calls? Yeah. So one thing I want to clarify, and actually I heard this as we were talking about it. The configuration file that expresses a mapping between Oso's data model of facts and your kind of like SQL databases. We're using that information to generate SQL queries, SQL filters that you run inside your application. Right. So when Vijay showed the like authorization filter equals oso.listLocal, that's basically asking Oso to generate that SQL fragment based on the policy and that configuration file. Oso doesn't talk to your database at all in that interaction. All it's doing is returning you like a SQL fragment that your database itself can, or like rather your application can like append to its own SQL queries and filters and things like that. And so however you talk to your database is how that kind of gets integrated. Those are some great questions. Cool. Yeah, open source. We're gonna basically have more news on open source coming in the next couple of months. Basically, in building out this distributed authorization and some of the technology behind it, we've pretty much re-implemented, well, actually, definitely not pretty much. We've definitely re-implemented sort of the entirety of Polar in that time. And right now we're basically figuring out with the new form factor, like the right way to draw boundaries around and open source it in a way that's kind of most easily consumable for people. But it basically, in short, yeah, stay tuned. More open source news on this coming soon. I don't know, in some ways you can kind of see this as well as part of us like talking more about the stuff that we've built here at Oso and opening it up. That kind of segues me a little bit into this kind of deep dive portion, which is talking about just how did we do that thing that Vijay was showing, right? Like we started out with an authorization question like, well, I guess Vijay was the more broader version of this, but can John close an issue, or what are all the issues a user can close? We started out with that like thing that we call like a query, it's an authorization question, and we output some SQL at the end that your application can run against the database. And so something I want to talk through now is basically like how do we do that? How do we go through those steps? To get there, basically where I need to start is kind of talking through a little bit of like how Polar works and like what Polar is. Make sure I'm sharing desktop. Yep. Cool. All right, so on the left in my editor here, I have a small example of a Polar policy. Right, so Polar is a language that we developed here at Oso for expressing authorization logic. It's a declarative, like logic-based language. And so I'm going to kind of talk through the core properties of what that looks like and how that interacts with authorization. So again, the kinds of questions we're trying to answer here is like, can John close an issue? I'm going to be like showcasing whether we can answer that question through these inline policy tests. So this is a test case with a name and an assertion that says, I'm asserting, I want to test, can John close issue 42? As things currently stand, I run this test and I'm going to get an assertion failure. This is failing. And that is expected because we haven't written anywhere in this policy anything. And like by default, nobody can do anything. That's kind of our starting out point. I can somewhat like truly give John, this ability by writing a rule. So rules inside Oso express, who can do what. And here is a nice example of a pretty minimal rule. It's so minimal, it doesn't even have any like conditions. So this is, equivalent saying, if true. So this rule is expressing that John is allowed to close issue 42 unconditionally. We often write this like this, and we call this a fact as well, which if you're paying attention, is also our data model. So we're going to come back to that. But this here is basically a piece of logical information that we're expressing that says unconditionally John can close issue 42. So now when I run this test again, this test passes. And so we just wrote some authorization logic and we tested it that succeeded. The way that Oso and Polar is evaluating this expression and like this test is through a logical process that's made up of like two really like fundamental technical like pieces. One is a thing called unification and the other is around like inference and rule inference. So to show you the unification process, I'm going to make this rule look a little bit more different. I'm going to change this from being a concrete user to an input variable user with a type. And I'm going to say this rule is true. So users can close issues if, and I'm just going to hard code that the user is equal to user John. It's kind of equivalent to what I had before, but what I'm doing here is making that unification process much more explicit. It looks like equality. Unification is kind of like it's like fancy pattern matching. It can look like, this is a check, does this user equal John? If, I can also just write things like x equals 1, and I'm effectively initializing a new variable to 1. I can then check, does x still equal 1, and this one is now going to return true, and things like that. And so this is all about unification. It's like pattern matching. Does this thing equal this thing? Maybe if not, assign the variable, things like that. And so I can kind of go through this process a little more. I can do, I can say, I can pull out the issue as well. So I've got two inputs, a user and an issue. And I still just want that the issue is going to be hard coded to 42. When I run this, everything should still be passing. And I can start expanding this as well. I can maybe add some additional ways that this thing is going to be true. I'm going to parenthesize this because all always confuses me and I never remember if I get it right. But I could say, or the user is some other user. Maybe it's user Alice. And the issue is instead going to be issue 111. Let's do this. Cool. Cool. So now I've got like a few different statements and things to check. And I can write additional tests to say, well, what about can John close 1111? I run these tests and the second one fails. And that is kind of expected, right? We're saying either the user is John and the issue is 42, or the user is Alice and the issue is 111. And so we're starting to see here is like the unification process is going through here and it's doing these comparisons and making sure that all these things are like checking and comparing correctly and pattern matching. So that's kind of like part one of the logic programming is like going through and comparing or assigning these values. What about the inference part? So this is kind of painful to like write all this stuff out. This is not a great policy. I want to kind of like start adding some like reusable abstractions. And here I'm like, okay, there's like a concept of like users that can close issues. So I'm going to write a rule that says, can close issue. And I'm going to continue just hard coding these for now. I don't need to figure out, these can be abstracted later, but okay, so I've got John closing 42, Alice closing 111, and I can now replace this with a call to that rule. So this is when I was talking about inference and like rule inference where this piece comes in, right? So like I'm now saying a user, like abstractly, users can close issues if the can close issue rule is true for those two same inputs. And so basically, so again, what's happening is Oso's following through that kind of same like unification where it's using it to like compare and set values to be equal, plus like, going through and evaluating different rules. And so indeed, again, John still can't close issue 111, but that's correct. So I'm going to have that as a negative assertion. Right, so we run these tests. John, cool, our tests are passing. John can close 42, but not 111. All right, this is like a very, very, very minimal example of Polar, just to kind of showcase there's like these two core building blocks of writing authorization logic here. And it's basically its ability to pull logic out into these kind of concepts of rules that start and like reusing them to express and kind of compose authorization logic together. These are the same fundamentals that's happening in the policy that Vijay showed you earlier, right? Like the flows if manage issues on a repository. It's shorthand syntax here for like writing these rules to allow it to be a little more concise and scannable, but it's using all the same concepts. So this says like a user has permission to close an issue if they have the permission to manage issues on a repository that the issue is like related to. And those are all themselves just, again, like there's going to be unification going on there where we're like comparing the closed permission against like the thing someone's trying to do. When we're asking, does a user have manage issues permission? We're going to look at like, well, they can have manage issues permission if they have the editor role. That's using the rule inference, and like, and on and on and on. It's all just kind of like going through and expanding out these different rules and finding like what things match and what things work. So that's the logic side of things. We spoke about like the facts in the data model. So typically like this kind of information here, we think of as being data. This is like concrete information we want to assert about the world. And so it'd be really painful if I had to like manage this by appending strings onto my like policy file and managing that way. And so we generally don't. Like Oso manages information like this in its own database with its model called facts. I can kind of show that inside this test case by moving this into a test setup block. So this is kind of a way of writing for a test case like ephemeral data that I'm going to use inside the test case. Right. So in this, by moving that, this test still succeeds. But in the scope of the policy doesn't actually know anything about who can close issues. So if I save this policy and like asked what can John do, it wouldn't know. And so like, there's like a little bit more that we're doing here, right? So one thing is like, okay, so we're like, data doesn't live inside the policy. And so what that means is that like policy evaluation time Oso doesn't actually know or use the knowledge of this data existing. It actually splits the process into two parts, where it first goes through and evaluates like this logic, and it says, okay, I know that users can close issues if this can close issue thing is true. Can close issue might exist inside my database, so I need to go and do a database lookup there. And actually, so what Oso is doing, and what Polar is doing, is outputting an intermediate representation that expresses what data we need to go and find to make these things be true. In our kind of Git Cloud example, this is what that intermediate representation might look like. So we have this representation that says, this is, for example, searching for issues that John can close. And we're saying, yeah, the actor in this case is John. The output is going to be a resource that is going to be from some output that I'll come back to in a second. But the data that needs to be true to evaluate, to find out which issues John can close, we need to find repositories related to some issue, and we need to find that like John is an editor of like some repository, plus some constraints that arg2 equals arg2, so like these two repositories are the same. This is like a minimal expression of the data Oso needs to find to evaluate issues that John can close, right? And in like plain words, John can close issues that belong to a repository for which he is an editor of. And that's like the lookup that we do. And so coming back to my little map, this is piece one. We take a query and we turn it into these data lookups. Now, in the centralized authorization world inside of Oso Cloud, at this point, we're actually done and we actually output SQL that Oso runs itself on its own database to go and evaluate the expression. But in the distributed authorization case, that's not what's happening, right? We're outputting SQL that's mapped to your own, to like the application's data schema. So we need to do more work here. Basically, what's happening is we're taking that YAML file that Vijay showed earlier, and we're using that mapping to identify data that the application knows about and not Oso, right? So this is declaring my application knows which repositories issues belong to. I'll handle that. Oso, don't you worry about that. And so when Oso goes through, it basically looks at this representation and it finds which facts, which data it should do in the application, and which data it can do inside of Oso itself. And so, for example, here is one of those kind of those queries that's been split, where we've identified that on the Oso side, we can evaluate, we want to find repositories belonging to organizations for which John is a member of. And that's going to give us a list of repositories. And here's the SQL that Oso is running. Suppose that gives us a list of repositories, right? Like, yeah, John has access to 65, 66, 67, things like that. That information is coming back to the application, as well as, or okay, so in this example, John has access to repository 1. The application now needs to evaluate like the rest of that binding, so the rest of that intermediate representation, based on the data that it knows and the bits that Oso already did. And so in this case, the application knows about issues belonging to repositories. It got back from Oso that John has the required permissions, which at this point we don't even know or care about, but it just knows that basically all it's getting back from Oso is John can close issues belonging to repository 1. And this is the thing that we then turn into SQL using that YAML file that we just showed, so that you can evaluate against your own database. And it's kind of nice, right? Because here we're seeing, right, like, so yeah, this expression is representing, yeah, John can close issues belonging to repository 1, and John can close issues where he's the creator. And that's what Vijay was showing you in that like SQL output. We're like generating the SQL for. And so that's kind of this final piece. Right, so we take this authorization question, we have this intermediate representation that in Oso Cloud world, we can evaluate entirely, but in distributed authorization, we can split up into chunks that can be handled by different databases, in particular, Oso in the application, but coming back to one of the questions from earlier, in a future state, it could be across multiple different databases. A little bit more of an interesting like query planning thing to happen there, but that's kind of where this would happen. But yeah, and ultimately, right, what we're getting back is a SQL expression the application can run that's expressing, based on the data it knows, and the sort of partially evaluated stuff from Oso, what's left to do. Cool, so at this point, and we had some fantastic questions earlier already. I see the chat is somewhat on fire as well. But yeah, basically happy to go, talk through any of the stuff we just covered in more detail around distributed authorization in the use cases, like how the Oso part is working, what the integration looks like, or any other questions people have. I'm going to catch up on chat in the meantime as well and see if there's any must answer ones.
While Sam catches up on the chat, I wanted to give an opportunity to David Park from the company Kaleidoscope to say a bit about how this feature has been useful for how they use Oso at Kaleidoscope. So, David, over to you if you're open to it.
Yeah, sure. Hi, thanks Vijay, and thanks Sam for the presentation. We currently the way that we have our auth set up is that we would sort of pull a lot of the information that Oso needs to determine whether something has access to something or not. And we cobble that together as a context which we send to Oso. And so I guess this sort of would bypass all of that because it would just, like you're saying, Sam, return us that SQL query so that all of this happens in-house. So every additional service that we introduce to our app, we would have to sort of make corresponding functions to cobble together that context object to send to Oso. But now we wouldn't have to do any of that. So this would simplify a lot of the permissioning on the app.
Awesome. Thank you for sharing.
Yeah, thank you for sharing that. And yeah, we're always excited to find people who want help integrating this or like work together to flesh out any details or make the experience as good as we can. I see some good questions as well in the chat, which I'll kind of go through. So there's a question around like tooling or an SDK to help like translate the output Oso returns to the database lookup API call. So currently that is the only way to use this, is that the Oso is returning you that SQL fragment. Gabe, you're just saying the exact same thing. This is great. It's returning that SQL fragment that you're using to run against your database queries. And so when we talk about things like Postgres support or MySQL support, we're basically talking about like Oso is doing that work today of like generating you the like database dialect specific output that you run. In the future, we are interested in potentially opening up that intermediate representation that I was showing. If we can find like a good way of representing that and exposing it, returning that to allow people to build like their own adapters, their own integrations on top of it and things like that. Because yeah, similarly, I've heard some interesting ideas around like if people could get back that representation, they could go and make like an RPC call to go get the data they need, or like potentially act on it in their own ways, which I think is a really interesting angle for extensibility. So many good questions. This is great. I'm going to go through some of them pretty quickly. Any plans to support MySQL? Like 100%. That is definitely coming soon. It'd be cool if there an independent library that could. Another question. Cool. Yeah, I definitely one of the things we're like really interested in understanding or discussing with people is like the right some of the right integration points. Like I think that configuration format that we showed is a very it's a very easy, flexible one today. Like kind of if you can write it as SQL, then it'll work. But definitely sort of some of the things that could be really helpful is having some of that work maybe done just by the ORM by default. And we have kind of like we sort of have some best practices that we are going to be documenting soon around like how to think of mapping your data model to Oso, where it's things like if you have foreign key constraints between tables, that's probably a has relation fact and stuff like that. So I could definitely see that being a good experience for like a have opinionated integration with ORMs. So many questions. I feel bad like zooming through these, and also like I feel like this is just me talking right now. So I might try and call on some people to ask these out live as well. Oh yeah, Martin, that's a great question. Do you wanna ask it out live? I'm gonna pick on you.
Sure thing. We have a central repository of the policy at our job. I'm sorry, I'm not visible. It's dark here.
It's all good.
Yeah, and we are versioning in GitHub, right? So if the data binding is touching only services, right, that's another repository completely. So if I need to do migration, I have two repositories to care of right now, like with the query binding. So how should that be like versioned or?
Yeah, it's a great question. It's a thing we spent a bunch of time thinking about the right approach for as well, which yeah, you're creating this ability for the individual services to maybe be independent from the central authorization service, but there is this like policy element where there is that independency where it's like the things you want to express, right? Like I want to express that users can close issues based on a piece of data that's living in the policy, but the description of the data lives inside my app. What we have found, I guess like what we discussed and sort of landed on is the right balance there is those like YAML files to express the data mapping, those live inside the application because that allows you to, for example, introduce new pieces of data or make like schema changes without needing to like coordinate that with a like new like migration path. Right? Like you update you change the data model, you update the YAML file, and like you can have both versions, blue-green deploy, you can have both versions running at the same time and have confidence that they're running the right queries against their their view of the database. Basically what that does mean is like, yeah, if you're like introducing new kinds of data, you sort of have this like staged approach where you would like add the new data information to the bindings file, the YAML file. Then you're able to like update your policy to make use of that new piece of information. So you kind of like drive things that way. So kind of the way I think about it is like, yeah, on that application team, you're asking that question of like, okay, like what kind of authorization do I want to perform? What data do we want to use? And so that kind of drives the evolution of that configuration file. Whereas the policy still gets to just be that kind of like central source of truth for what authorization logic happens. I think one of the things we're thinking about kind of revisiting in the future is there a different way of distributing the policy itself as well to kind of like help some of those boundaries become a bit clearer? I think in particular, like we see a lot of people break down their policies and manage it across service boundaries already, kind of from a contribution model. It makes a lot of sense. And so there's maybe some ways there that we could think about like versioning policies across those boundaries. It's a great question. All right, I see Gabe is quick on the mark again with some of these questions, but yeah, for plans for kind of to reiterate some of the points I was making earlier, are like roadmap for database support. I think the kind of SQL that we write today is pretty standard. So we kind of see in the short term adding support for multiple different relational databases is going to be an easy win for us. For different data models, so in particular like document data stores, NoSQL, things like that. I think there's a little bit more work and thinking for us to do to find the right way to do those integrations. And so it's kind of, we're not committing to that in like the immediate term, but it's definitely on like the longer term roadmap. And for people who have that use case, like we're definitely interested in kind of discussing and partnering with them on those kinds of things as soon as possible. All right, this has been a fantastic session. I have another meeting in 2 minutes, so I think that's probably a good place for us to wrap it up. Bang on time. Thank you all for joining us. This is a great session, and there's some phenomenal questions. Doesn't need to be the end of the conversation. Steffi is on the ball as always. Yeah, if you want to continue the conversation, please come join us in our community Slack. You can also just like reach out to us, set up a call if this is something you're like interested in, using at your at your company.